All right, is there anyone who doesn't have the chapter 12 sheet? Okay, anyone else? Please have that. Okay, so we are using this IUPAC naming. This means that anyone in the world who names a chemical and you follow this, then everyone's going to name it exactly the same way. And so it's kind of like we're learning all of these rules. There's always exceptions, but generally this is how we name compounds, organic compounds. Oh. Okay. Great. So this is, you don't need to know this, but I think this is interesting. Most drugs have at least two different names. They have a systematic name, which is what we're learning, the IUPAC name based on the structure. So this is where this group is, this is where this group is, this is the backbone. This is a generic brand, so like ibuprofen would be our generic brand, and then Motrin or Advil, they have done something that they're saying like this is the same compound, but I crystallized it differently, or I made it a certain way, so they have their trade name. So we're learning this is the same compound, the systematic generic trade name, but the systematic name, if we follow the IUPAC naming, everyone in the world will name it the same way. And we know what the structure is based on the name. Okay. All right, so this is, I don't think this is on here, but this is basically how we name organic molecules. So we have a parent's name, that's usually our longest carbon chain. And then our prefix tells us any groups or branches we have and where they are. And then the suffix tells us if we have anything special. So if there's a double bond, or if there's an aldehyde group, the suffix is where we're going to learn that. So right now, in chapter 12, we will use prefixes and our parent chain, and the suffix is going to be A, because it's only single bonds. In chapter 13, we'll look at somewhere we'll have double bonds and triple bonds, and we'll change the suffix. But right now, our suffix is ane. Okay. All right, and we're going to continue with our rules. And our rules are here, so you don't have to write them down. So you're going to find the longest continuous carbon chain, and because it doesn't have anything special, the ending is ane. And then you're going to number the atoms in the carbon chain. You want the first substituent to have the lowest number. We already talked about that. And then you're going to name the substituents as alkyl groups. And we talked about that these two boxes. This is the one that you'll use for Alex. These are the substituents. You have to recognize those, and you'll tell me where the substituent is and what it is. Okay. Great. So we have all of those. Okay, I think we've talked about this already. Each substituent needs its own number. Even if we have like two at the same spot, we have to say 2, 2 to show that there's two of that same group at the same spot, or 4, 4. Okay, we'll look at some examples. If we have two groups at the 2 position, we'll have to say di. Or if we have 3 groups at the 4 position, we'll have to say tri. Try whatever it is. Okay. I think if we go over some examples, it'll make more sense. All right, here are some more rules. Also, these are in that box. You're going to alphabetize the substituents, ignoring prefixes. So we have substituents. We have chloro, methyl, ethyl, propyl, isopropyl. So chloro starts with a C. It will come before all of them. Ethyl starts with an E. It comes before methyl. Isopropyl starts with an I. It comes before methyl and propyl. Okay, so based on the substituent, you alphabetize them if you have more than one. Let's see, is there an example on here? There's not. We'll look at some examples. But the number, so you put your number, then you put a dash to your prefix, your substituent, and then there's no space, there's no dash, there's no comma between the substituent and the parent carbon. Okay. If you have multiple numbers next to each other, you put a comma between them. So we'll look at some examples. Okay, here's an example, and then we'll look at some in Alex. So this substituent, or this carbon chain, we will name number this way: 1, 2, 3, 4, 5, 6, because that reduces the first to the 2 position, and then that will put 2 numbers on the 4 position. And so then we're going to, these are all methyl groups. So we are going to call this 2, comma 2, comma 4, comma 4, and then there's no dash, we use a dash. Tetra, because there's 4. Tetramethyl hexane, because it's a 6 carbon chain. Okay? So this is just like a board name. You just have to go through your list of rules. Okay? Anyone else in the world using IUPAC? So it's International Pure Applied Chemical something. Everyone else will be using IUPAC. They will also name that the same way. So that's why we are using these rules. Okay. All right, let's go to Alex and do some examples. Oh, no. There's a sort of clips going on. I think maybe that's what they're looking at. It's not quite. Is that what it's not doing? So I would take my own report. I did well. Let's see. How much last time, right? Yeah, we have an hour. Okay, let's also throw in, we'll just really quick go over what cyclic means, and we'll just do all the topics. We'll see how far we get. We went over half of them last time. Okay, so the other part of naming, the other rules, or adding more rules, if it has a circle, a cycle in it, then you're going to add that to the name. So you're going to have some branches in the prefix, tell me where they are and what they are. Then you're going to add cyclo, so it might be like cyclohexane or cyclopentane. If it has a ring structure, you need to put cyclo in the name. I think that's one of the most missed questions on the test last year. People they forgot. They're like, oh, it has 6 carbons, it's hexane. No, you need to make sure that you tell me that it's cyclohexane. Okay, so practice that, and then if there's a question, we don't have to use them. Okay, so we're going to count the carbons in the ring. If there's a circle, a ring structure. So this one has 1, 2, 3, 4, 5, 6. When we number this, we want to minimize the number, the first group. Oops. So we could either count this as 1, 2, 3, 4. Okay, we're down to 4. Or we can count this as, let's change color. 1, 2, 3. So what is this group? This one has 2 carbons. So this one's an ethyl group. This one's a methyl group. So which direction should we number it? We can number it this way or this way. We're going to number it this way because we want the prefix ethyl to go first before methyl. Because ethyl comes alphabetically first before methyl. Great. So this would be called 1-ethyl dash 1, 2, 3 dash methyl, and then it has a circle in it, a ring structure, so I have to put cyclo. Don't forget that. And then there's 6 carbons in the ring, 1, 2, 3, 4, 5, 6. I think I counted the wrong way. 4, let's do 1, 2, 3, 4, 5, 6. Okay. Cyclohexane. Some other tips is that if it's octane, then you keep both of the O's. Cyclooctane. Okay. Alex will mark you wrong if you only put one O. So make sure if you come across cyclooctane, use both O's. All right. Let's see. Okay. You can, if you have only one substituent, then you don't need to put the number. You can. This would be 1-methyl cyclohexane. This one would be 1-butyl cyclohexane. We don't use butyl, I don't think, but in our class, but it's not there. Okay. So this would be 1-butyl cyclohexane. Make sure that you put cyclo in front of the ring structure.
If we do put one more, right?
Yes, it should. In the past, I think it has. So you don't have to put a number, but you can. Okay. Okay. If there's a ring with 2 or more substituents, you're going to begin. We talked about this. Begin numbering at one substituent. Go around the ring to get the second substituent, the lower number. So the other way we could have gone this way. 1, 2, 3, 4, 5. But can you see if I go this way, they're shorter. So I'm going to number so that they're both at a smaller number. I want to prioritize alphabetically what comes first. Let's see. If there's more than one substituent and they all have the same priority, number the ring so the sum of the locants is as small as possible. So make sure they have the lowest number possible. Let's see. And we talked about alphabetically. If there's 2 competing ones that are in the same position, either way, then you should alphabetically prioritize them. Okay, let's go back to Alex. I think now we'll do any of the topics that come up. The first one, I think that should be open for you is understanding the basic descriptive vocabulary. Do you have that one? Of molecules with? Great. I don't know what the rest of that is. So here we go. Draw a skeletal. That means no, we're just drawing the corners and vertices. Skeletal structure of a cyclic ketone. Oh, we have to remember what a ketone is from chapter 11. With 5 carbons in the ring and 2 methyl group substituents. Okay, and it's not really telling me where they are, so I can pick where they go. The first thing, the space thing is 5 carbons in the ring. So I'm going to start. I'm going to do my best. This one might be one where Alex is kind of picky, so I'm going to do my best at making a beautiful. Oh, it's going to fix it for me. Great. So I have my cyclic carbon base structure, and then I need a ketone. Do you remember what a ketone is? A ketone is a carbon double bond to oxygen. So I'm just going to put it here. It doesn't matter where it goes because they didn't tell me where it should go. So we've got a cyclic ketone with 5 carbons in the ring and 2 methyl group substituents. So I'm going to put a methyl over here and a methyl over here. It has 2 methyl group substituents. Doesn't matter where they are because it didn't ask me to put them in a certain spot. Okay, let's check. Okay, you could have put your methyls over here, you could put one over here, one over here. You could not put your methyl substituents on here because this carbon already has 4 bonds. All right, let's do this one a few more times. This one has all sorts of things it's asking me before. Draw the skeletal line structure of a carboxylic acid with 2 carbons in the main chain and no substituents. Okay, 2 carbons in the main chain. I'm going to draw something like this. And then carboxylic acid. Ooh, what is that? So I might have to look at my notes from chapter 11, but I know that a carboxylic acid has a double bond oxygen right next to an OH group. Oh, this is on the left, so I'm going to use this box to type HO so that the O is connected to the carbon. And it's a skeletal structure. So I'm still not drawing the carbons. I'm not drawing a condensed structure. So let me double check. Carboxylic acid. Okay, that's my carboxylic acid with 2 carbons, 1, 2 in the main chain, no substituents. So I think that's good. Great. Let's do another one. Skeletal structure of a ketone. Okay, we already looked at ketone with 4 carbons in the main chain and no substituents. 1, 2, 3, 4. 1, 2, 3, 4, and then a ketone. It doesn't matter where it is, so I'm going to put it right here because that's easy for me. Ketone is a carbon double bond to oxygen, nothing else. Nothing else. Okay. Okay, do you want to do more? Let's do one more. Let's see if we can come up with anything else. Okay. Ooh, amine. Structure of an amine with 3 carbons in the main chain and 1 methyl group substituent. Okay, 3 carbons in the main chain. 1, 2, 3. And then do you remember what an amine group is? It's just NH2. Amino. So, and then I'm going to put a methyl group. 1 methyl group substituent. I don't know, this one, I'm going to put my methyl group over here. I can't tell in this sentence if they want the methyl group off of the amine, because I could put a N methyl group with an H. I'm going to put it like this and see what they think. Okay, that's fine. Great. Okay, questions on this. So this is building off of chapter 11. So you do have to remember what those functional groups are, or you're going to have to write them on your note card for chapter 12. All right, let's move on, and we can come back if we need to. Let me find my list of topics so that they're in the right order for you. Let's see. All right, so we've got this on understanding. We did all these last time. Let's see what else we have. Naming the parent hydrocarbon, we did that. Using multiple apexes.
So good.
multiple affixes. Oh, here. So we haven't done this one. Using multiple affixes. Okay, so we're just gotta know the names of these ones. So this is like, again, this reminds me of playing a board game. You have to play the game a lot so that you know all the rules. You're ready for any situation that comes up. Okay? All right, so we're going to do what we did last time. We're going to number this based on the longest carbon chain. I'm looking to decide if, okay, I don't think it matters. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, doesn't matter. Also, any way I count this, the carbon chain, any way I number the carbon chain, I'm going to have a methyl and an ethyl group. So it doesn't matter which direction. So I'm just going to start over here. 1, 2, 3. I have, at the 3 position, I have an ethyl group and, or excuse me, a methyl group and an ethyl group. So 1, 2, 3, 4, 5. So our parent chain is pentane. And then off of pentane, I have a methyl group at the 3 position and an ethyl group at the 3 position. Let me write this out. I think that will get this. So I'm going to count it like this. 1, 2, 3, 4, 5. My methyl group is at 3. So this will be called 3-methyl. Oh, that's not negative. 3-methyl, and then I have an ethyl at the 3 position. So this will be 3-ethyl.
What if you had like 2-methyl and it cuts off?
2 methyls, then you'll have dimethyl. Yours will be like,
so 2 dimethyl.
but is it at the 2 position? So 2, 2 dimethyl. 2, 2 dimethyl. Dash. Here. So it would be 2, 2 dash dimethyl. All right, so which one goes first? They're at the same position, so we're going to alphabetize them. So we got 3-ethyl. Ethyl will go first because alphabetically it's first. 3-ethyl dash 3 dash methyl. And then no space, no dash, no comma between the last thing and the compound. Okay, next one. So this one also, no matter which direction I count it, if I count it this way or this way, it's going to be the same. So this is 1, 2, 3, 4, 5. If you're not convinced, if I count this way, 1, 2, it'll be the same. Okay, so at the 2 position, I have a methyl. So this is 2-methyl. This one is 4-methyl. The parent chain is pentane. I don't know if I said this, but the carbon is either in the chain or it's a side group. It can't be in both. So it can either be part of the main chain or it can be a side chain. All right, so our parent chain is heptane. Spell it correctly, heptane. And then we have 2 methyl groups. One is at the 2 position. One is at the 4 position. And we have 2 of them, so I'm going to call it dimethyl. So this is 2, 4 dash dimethyl heptane. Oh, pentane, thank you. Thank you for catching that. Great, thank you. Okay, last one. This one is also pentane. It's like 1, 2, 3, 4, 5. So this one also, no matter which direction I count it, it's going to have 5 carbons. Oops. Why is it not? Oh, it's because no. 1, 2, 3, 4, 5. I'm going to number this way because then I'll have 2 methyl groups at the 2 position instead of if I count this way. 1, 2, 3, 4. These will be at the 4 position. I want to reduce the number that they have. So we're going to go this way. 1, 2, and I have 2 methyl. And this one is also 2 methyl. We've got pentane. And there's two of them, and they're both at the 2. But I do have to tell you that they're each at the 2. So this is going to be 2, 2 dash dimethyl pentane. There's 2 methyls. They're both at the 2 position, and they're on this pentane branch or chain. Okay, questions so far? Let's do some more. Let's check first. This is really picky. Make sure you spell everything right. Make sure you put the dash in the right spot. Make sure you put the commas in the right spot. Make sure you count correctly. It's very tedious, but once you get the rules down, it's not so bad. This is something that the more you practice, the better you'll get at it. It's like a skill you have to build. Draw the skeletal line structure of an aldehyde with 4 carbons in the main chain. Oh, did I push the right thing? No, I didn't. Sorry. We already did that one. Okay. We're back to using multiple affixes in the name of the branch. Okay. So this one, they're trying to trick us. It kind of curves. I can get 1, 2, 3, 4, 5. I can get another. This is the same one we already did. I can get a pentane out of this. Does it help to number it? So we got 1, 2, 3, 4, 5. I'm going to count that in my chain because then the chain is longer. I want to find the longest carbon chain. And then I have 2 methyl groups at the 2 position. So this is the same one we just did. 2, 2 dash dimethyl pentane. Just because they put this carbon chain up here doesn't mean that it's a different molecule. They just drew it differently. It's like someone holding their arm up in the air versus like holding their arm down there. It's like the same person. You still name them the same. Okay, next one. Oh, a long one. Let's see. So it looks like I'm going to see. Let me count through this middle. This looks pretty long. Let me see if I can get a long carbon chain this way. So I'm going to count. Let's count this way first. 1, 2, 3, 4, 5, 6, 7. Another way I can count this is 1, 2, 3, 4, 5, 6, 7. If I count this way, or this way, it's both heptane, and then the side chain is pentane, not pentane, propane. So either of these is the same. Okay, so it doesn't matter that way, but I do need to know if I should count this way or if I should count from the top down. So this way, there's an ethyl and a propyl at 4, and a methyl at 3. If I go the other way, 1, 2, 3, 4, 5, 6, 7. Then this is also at the 4 position, and now the methyl group's at the 5 position. So I'm going to start down here, 1, 2, 3, because the methyl group will be at the 3 position. So I'm reducing the first group that I can. Let it go that way. I'm going to say 1, 2, 3, 4, 5, 6, 7. And then the groups that I have is this will be 3 methyl. And then over here we have 4 ethyl. And we have 4, we also have a 4 propyl. Okay. And then I need to, when I put them in the name, I need to alphabetize them. So ethyl is going to go first, because it starts with an E. And then in alphabet, I think N comes next. And then no P, so this one is second. And then this will be third. And then E. So you alphabetize the branches. All right, so let's go through that. So then our main chain has 7, so it's heptane. Okay, so I think we have all the pieces. We have 4 dash ethyl dash 3 dash methyl dash 4 dash propyl. This is a normal propyl. Oops, make sure you spell it right. Propyl. And then heptane is the main chain.
When do we use a comma?
If there's two next to each other, two letters next to each other.
Oh.
So this had two methyl groups
Oh.
right here. Good question. Other questions? Okay, one more box and then we'll check, make sure we're doing it right. Okay, so this one, yeah, either way, I think we did this one already. 1, 2, 3, 4, 5. If I number it this way or number it this way, they'll both be up to 3. We have a 3 methyl. We have a 3 ethyl. And then this is pentane. And ethyl goes first. 3 dash ethyl dash 3 dash methyl. No space. Pentane. So lots of little rules to remember, lots of little things to do, to keep track of. Very tedious. Alex is very strict, but once you have these rules down, it's not so bad. Okay, questions on this? Do you think you could do this one? Do you want to do another one of these together? Okay. Yeah, this is something that I think the best thing to do is just to do lots of examples to convince yourself that you know the rules to follow. Okay, let's go to the next topic on our list. Naming and drawing normal alkanes. Okay, let's do that one. Naming and drawing normal. We already did that one. We already did that one. Yeah, we already did that one. Okay, that's normal means no branches. Okay. Branch. Naming and drawing branch. Okay, we can find that one. Okay, so same thing we've just been doing. Just now we can have chloro as an alkane. All right, so I'm gonna count this. I can see, I've been practicing. I can see that this, if I go this way, 1, 2, 3, 4, 5, then this is gonna reduce our first branch. If we go the other way, 1, 2, 3, the chloro is at the 3 position, but this way my methyl group is at the 2 position. So I'm gonna go this way. So I'm gonna have 2 methyl, and then this is chloro. If I go 2 methyl, then this is 5 chloro. Chloro comes first before methyl because of alphabetizing. So we're going to put this one first in the name and this one second. And then our parent chain is heptane. So this one will be 5 dash chloro dash 2 dash methyl, and then no space, no dash, heptane. Heptane. Great. All right. 1, 2. Okay, I'm going this way. 1, 2. So this methyl group is at the 2 position. 2 dash methyl dash. The parent chain is 1, 2, 3, 4, 5 pentane. Okay, last one on this. Okay, let's count this one out. So I'm going to start over here because the methyl group looks like it's closer to the end and this one is closer to 5. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So we've got an octane main chain. We have a methyl at the 2 position. And we have an ethyl at the 4 position. Ethyl comes alphabetically before methyl, so this one's going to go first in the name, and this one's going to go second. So this is going to be 4-ethyl dash 2-methyl, and then no dash, no comma, no space. We're going to put octane. Oh, spell it right. 4-ethyl 2-methyl octane. Oh, something is wrong. Oh, I have a dash here. So I didn't have a dash there. Okay, great. Okay, how is that one? Is it naming? Oh, naming and drawing. So let's try a drawing one. Oops, not next topic. Oops. Go back to this one. Let's try the drawing version. Draw the condensed structure. So when it says condensed, you need to make sure that you are drawing the carbons next to the hydrogens, not showing the bonds for carbon and hydrogen. So make sure you draw the correct thing. Condensed structure of 2,4,5 trimethyl heptane. So the first thing that I'm going to do is I'm going to draw heptane. So heptane has a CH3, and then a CH2, and then another CH2, 1, 2, 3, and then another CH2, oh, then another one. Let's see, how many? 1, 2, 3, oh, one more. 1, 2, 3, 4, 5, and then the ends are methyl groups. Okay, so this would be heptane. Now I'm going to add the branches to heptane. So the branches, that tells me I have 3 methyl groups. One at the 2 position, one at the 4 position, one at the 5 position. It doesn't matter which side you start from, just be consistent. I'm going to start from the left side. Doesn't matter. Okay, I'm going to put a methyl group here. I think we talked about this in this class. If I put a methyl group here, I need to go back here and change this to a CH group. Okay, carbons can only have 4 bonds. So now this is showing carbon has 4 bonds. The other way you could do this is you could figure it out and draw it out correctly to begin with, but this makes the most sense to me. All right, 1, 2, 3, 4. We're at the 4 position. We also need a methyl group. I'm going to put a methyl group, but then this carbon has 5 things attached to it, so I just need to reduce the number of hydrogens. So now carbon is bonded to 4 different things, and then 5. So this would be methyl also. And I'm going to do the same thing here. This should only be a CH group. Okay, questions on that. So make sure you're paying attention. Some of these ask for the condensed structure, and some of them ask for the skeletal structure. So pay attention, make sure you're doing the right one. Okay. Do you want to try another one of the drawing ones or the box one? The drawing? Okay. So I just have to skip. Let's see. Is this one okay, or do you want to try this one? You got that one? Okay, let's do the drawing one. I can't see through. Okay, great. So this one's saying skeletal structure, so make sure you draw just the lines. Skeletal structure of 2,5-dimethyl heptane. Great. Heptane is 7. 1, 2, 3, 4, 5, 6, 7. All right, and at the 2 position, I need a methyl group, and at the 1, 2, 3, 4, 5 group, I need a methyl group. 1, 2, 3, 4, 5. Okay. So just following the instructions to draw the molecule. Does that make sense? You good? Okay. All right. Let's see. Let's go to, I think we just have the cyclic ones left. We got less time. We'll leave that. Great. Okay, the next one says naming and drawing simple substituted cycloalkanes. All right, so the first thing that I'm going to look for is the name of the ring. So count how many things are in the, how many carbons are in the ring. So corners are carbons. 1, 2, 3, 4, 5, 6. If this is hard to count on Alex, you could draw it on your paper and draw on your Alex, or on your paper. Count on your paper if you need. That's great. Okay, so the parent structure is cyclohexane. Make sure to put cyclo or it will mark it wrong. And I cannot give you partial points for not putting cyclo. Okay. All right, so then we just have to figure out the best way to number this. So what I'm seeing is if I go from like this one to this one, there's no gap carbon. So I'm probably going to number this as 1, 2, 3, 4, 5. So let's draw it out so you can see. I remember this 1, 2, 3, 4, 5. And you can either think about this as if you add up the numbers that you get, you want to make sure that they're lower. Or what I'm seeing is like if I put these two together, then 2 will be reduced. If I go like 1, if I do like 2, 2, then this one's got 1 and this one's got 3. So already I'm missing the bigger number. So that's what I'm going to do. I'm going to do 1, 2, 3, 4, 5. So then I have 1 methyl, 2 methyl, 4 methyl, 5 methyl. I'm not going to write that. So what we're going to do is we're going to say 1 methyl. We're going to do 1, comma 2, comma 4, comma 5. Dash. There's 4 methyl. So our prefix for 4 is tetra. Tetramethyl. Cyclohexane. And all of those together tell you exactly the molecules that I'm looking at. As long as I spelled it right. Okay, next one. Oh, there's some weird things happening. So this one, okay, my ring structure is pentane. So we've got cyclopentane, and let me help you decide how to count it. I'm going to again count next to each other, so I'm going to go like this 1, 2, 3, 4, 5. So then that reduces this first one, the next one right next to it. So together they would be, if I added 1 and 2, that's 3. I can't beat a sum of 3 on this molecule. So if I went like 1, 2, 3, 4, 5, then it'd be 1 plus 5. So that's not going to be good. If I remember it this way, 1, 2, then it's the same molecule. 1, 2, 3, that'll be the same thing. So it'd just be like flipping the molecule over, so that doesn't matter. All right, so the parent structure is cyclopentane. And then I have 2 ethyl groups. One is at the 1 position, one is at the 2 position. They are both ethyl, but it's going to be diethyl. Diethyl cyclopentane. Hopefully I spelled that right. Okay, and then the last one, we'll check our hypothesis. You can either just say this is methyl cyclopentane, because it doesn't matter, like it doesn't matter which carbon it's connected to, it's going to be identical. Or we could do, I don't know, I'm going to do 1 methyl cyclopentane. I think the biggest error that I remember seeing on the test last year was that people weren't putting cyclo when it was a cyclo. So maybe you're doing it in the homework, just make sure on the test you're also putting cyclo for a ring structure. Okay, let's check, make sure that I didn't miss anything. These are very picky. Okay, question so far. Let's do another one of those. So naming and drawing, great. We'll kind of go back and forth between. Naming and drawing. Draw a skeletal line structure of 2-chloro-1,3-dimethyl cyclopentane. Okay, so cyclopentane is the main structure. If you get this on the test, make sure if it says cyclo, you make a ring structure, don't just draw pentane. So pentane looks like a little box with a little, like, kind of like a little house. Oh great, and this can fix it for me. And then 1, 3, so I just put methyl over here, it doesn't really matter. And then I'm going to count around, so 2 chloro, I'm going to put a chloro group, and then another methyl. 1, 2, 3. 1, 3 dimethyl, 2 chloro, cyclopentane. So I would just go back through, take your time, double check that you have everything that they're asking for. Okay, let's do one of each of those again at least. More practice. So this is back to our naming cyclic structures. Okay, so this one is a pentane. And then, oh, we have 2 methyls. We just have to decide how to count them. So we could count like 1, 2, 3, 4. But I can see if I go this way, they're really close to each other. Instead of having 2 carbons in the middle, I'm going to have just 1 carbon. So I'm going to go 1, 2, 3. And they're both methyls. So I'm going to go 1, 1, 3, dash, that's a 0, dash, dimethyl pentane. One's out of the 1, one's out of 3, dimethyl pentane. Great. Okay, oh, this one's weird. We haven't seen a triangle before. Oh, yes, thank you. Cyclo. Good. I'm telling you to do that and I forgot. Cyclo. Good. What's this triangle? This is propane. Cyclopropane. Cyclopropane. I'm putting the cyclo there because I forgot last time. So thank you for reminding me that. And then we just have a methyl group. I'm going to put it at the 1 position. You could also say this is just methyl cyclopropane, but I feel like there's one that was picky about. So I just like to put 1 methyl cyclopropane. Great. Making sure I have everything. All right. Oh, this looks weird. Well, here's the ring. The ring is 1, 2, 3, 4, 5, 6. This is cyclohexane. Okay, and then we're gonna name the groups. We have a group here, a group here, a group here. Those are all ethyl groups. This one's kind of weird, so I'm gonna number this one. I've seen this one. I've seen this one before, so I know that I need to go this way. 1, 2, 3, 4. Okay. So I'm reducing the values of these numbers. I'm putting these right next to each other. And I'm starting with this one. That's going to be the best way. If I go this way, 1, 2, 3, 4, that's going to be 1 plus 3 is 4 plus 4 is 8. If I go this way, it's 1 plus 2 is 3 plus 4 is 7. So that reduces our total 7. Let me go this way. Counterclockwise, starting with that first ethyl. So I have 1 ethyl, 2 ethyl, and 4 ethyl. Where's the pen? Oh, there you go. 1, 2, 4, and then there's 3 ethyls. Dash tri ethyl cyclohexane. Okay. Make sure that seems reasonable. I think so. Great. Let's do one more drawing on this topic, and then we'll go to the last topic. Draw the skeletal line structure of ethyl cyclopropane. Oh, propane. What's that one? That's that triangle. Let's see if we can draw a triangle in Alex. And then they didn't give me a number. That's because there's only one group. It doesn't matter. I'm going to try my best to draw an ethyl group. So I'm going to draw straight up and then over. This is 2 carbons, 1, 2. That's ethyl. Ethyl cyclopropane. Okay. How are you feeling? You think you could go through this topic by yourself? You want to do another one? Or okay. One more topic. The last one is naming and drawing simple cyclic alkanes. So this is like the same thing, but I think maybe, oh, this is easier. Okay, so we just have to count. 1, 2, 3, 4, 5, 6, 7. That would be cycloheptane. Make sure you put cyclo if it's a circle, if it's a ring. 1, 2, 3, 4. Butane. Cyclobutane. This one is, we just saw this one. This one's cyclopentane. Oh no, propane. Excuse me, I just said propane. Propane. There we go. All right, let's do another one. Oh, cyclobutane. Oh, we just saw that. 1, 2, 3, 4, and it has to be connected. So that's cyclobutane. Oh, great. We just did some cyclobutane. These prefixes, if you haven't already figured that out, that's going to be helpful to know. The prefixes, we'll just keep using those. If you take organic chemistry, it'll just keep using those, so that'll be helpful to know. All right, this one's cyclohexane. 1, 2, 3, 4, 5, 6. Cyclohexane. Oh, make sure you put the cyclo because it's a ring structure. All right, I think we saw this one already. 1, 2, 3, 4, 5, 6, 7. Cycloheptane. Let's see if we get that. If you get cyclooctane, you have to keep both O's. Cycloheptane. They kind of did a house with like the kind of 4 at the bottom. Let's see. One, 2, 3, 4, 5, 6, 7, 8. Okay, this one's cyclooctane. We keep both O's. Cyclooctane. This one was cyclopropane. And this one is cyclobutane. Oops. Oh, check my spelling. Oh, I didn't put a C in this one. Cyclooctane, cyclopropane, Okay, I think I got that. All right, I think that's all of the topics that we have for this chapter. We have one more day scheduled for chapter 12, so we'll probably just do a work day. We might, actually, we'll have to talk about lab 11 first. And then, so next time we'll talk about lab 11. We'll do lab 11 on Friday. And then we'll do a review day, and then a test day, and then we'll be on chapter 13. Last chapter. Okay, questions for me right now? All right, we have 20 minutes left. So work on chapter 12. Work on your signature assignment. Work on any labs that you haven't turned in. I think. Oh, you could also review for the final.